In Activity 4, Inventing the Wheel, students examine how the wheel reduces the amount of force needed to move an object by reducing the amount of friction between the object and the surface over which it moves. Students first measure the amount of force needed to move an object a certain distance, and then observe how even the most primitive wheels reduce the amount of force needed to move an object, and therefore the amount of work performed. You will need the following materials from the kit: Activity Sheet 4, bricks tied with string from Activity 3, dowels, and a spring scale. You will also need to provide meter sticks. To prepare for the activity, make a copy of Activity Sheet 4 for each student. Each team of 4 students will need their brick with string tied around it from Activity 3, a spring scale, a meter stick, and 5 dowels. Make sure to clear some space for teams to conduct their experiments on the floor. To begin the activity, stimulate a discussion by asking students, other than using a lubricant, how can we reduce the amount of friction resulting from one surface passing over another? Accept all reasonable answers. If students do not think of wheels, ask, how do you think people who lived in ancient times moved heavy objects? What might they have placed under a heavy object to reduce the amount of friction between it and the ground? Explain to the class that to move heavy objects, people cut down trees and stripped them, and that the smooth trunks were placed beneath the heavy objects so that the objects could be rolled across the ground. Next, distribute Activity Sheet 4 and the materials. Have students place their meter sticks on the floor and instruct them to use the spring scale to measure the force required to pull the brick a distance of 15 centimeters. Have students calculate the amount of work performed by moving the brick and record their answers on Activity Sheet 4. Remind them that distances must be measured in meters for calculations of work in units of joules, and use the conversion 15 centimeters equals 0.15 meters. Have students predict whether they will need more or less force to pull the brick the same distance if this time they use dowels, and instruct them to record their predictions on their activity sheets. Next, tell students to place 5 dowels side by side on the floor and then place the brick on top of the dowels. Instruct students to measure the amount of force needed to move the brick over the dowels a distance of 15 centimeters. As the brick rolls forward, the dowels will drop off behind it. To move the brick the full 15 centimeters, set the bricks on the last 2 dowels in their lineup, and then pull the brick toward them so that it slides over all the dowels before it begins to lose them from behind. Then, have the students calculate the amount of work performed and record their answers on their activity sheets. After all the teams have finished, tell the students to answer questions 6 and 7 on their activity sheets. Ask students, did you need more force or less force to move the brick when using the dowels? Students should answer that they needed less force to move the brick. Have the students use their data to support their answer. Then ask, why do you think less force was needed to move the brick when it was on the dowels? Students should respond that the dowels allowed the brick to roll across the floor with less friction than if the brick had been set directly on the floor and dragged across it. Next, ask students, what modern-day objects are like dowels in that they help us move heavy things from one place to another? Students may mention a wheel, which is a disc that turns around an axis and transfers force to and from an axle. Point out that ancient people probably adapted the wheel from trees, which were, in effect, giant dowels that they used to move heavy objects. To conclude the activity, tell students to return the dowels and spring scales to the kit. They should remove the strings from the bricks and discard them. Make sure to save the bricks for use in Activity 9. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.